Today, let's look at this question regarding the distance of two numbers. Suppose a, b, and are positive integers such that a is greater than b and a times b minus 1 equals to n squared. You are asked to show that the distance of a and b, which is a minus b, is at least square root of 4n minus 3. Please have a good try before you look at the answer. You may try to understand the question by listing out some possible value of a, b, and n. So suppose n equals to 1, then ab is equals to n squared plus 1, that is equals to 2. And in this case, there's only one possibility, that is a equals to 2 and b equals to 1. So a minus b is equals to 1. On the other hand, square root of 4n minus 3 is equals to 1. In this case, a minus b is greater than or equals to square root of 4n minus 1. Now when n equals to 2, ab is equals to n squared plus 1, that is equals to 5. And in this case, obviously, a equals to 5 and b equals to 1. So a minus b is equals to 4. And square root of 4n minus 3 in this case is square root of 5. Obviously, 4 is greater than square root of 5. Now when n equals to 3, ab equals to n squared plus 1, that is equals to 10. It can be equals to 10 times 1 or 5 times 2. In order to make a minus b smaller, then we will choose a equals to 5 and b equals to 2. Then a minus b equals to 3. And square root of 4n minus 3 is equals to 3 in this case. And again, a minus b is greater than or equals to square root of 4n minus 3. You can try for different value of n and you see that a minus b indeed is greater than or equals to square root of 4n minus 3. So for myself, my first try is try to square both sides and see a comparison. So I'm hoping to say that a minus b squared is greater than or equals to 4n minus 3. But when I squared it, I have a squared plus b squared minus 2ab, and this is 4n minus 3. But I still can't see what is the relation between these two expressions. After some trial and error, I finally figured out a way to go about it. So from the relation ab minus 1 equals to n squared, we have b is equals to n squared plus 1 over a. And this will mean that a plus b will be greater than or equals to 2 square root of ab using AMGN inequality. And this is equals to 2 square root of ab is n squared plus 1. And of course, square root of n squared plus 1 greater than n. So this is greater than 2n. Because a plus b are integer and the sum is greater than 2n, and therefore a plus b is at least 2n plus 1. This inequality of a plus b greater than or equals to 2n plus 1 gives us a great help. This relation of a plus b greater than or equals to 2n plus 1 is very important because we have the relation of a minus b squared is equals to a plus b squared minus 4ab. Because a plus b is greater than or equals to 2n plus 1, so this is greater than 2n plus 1 squared minus 4. ab is equals to n squared plus 1, and this is equals to 4n squared plus 4n plus 1 minus 4n squared plus 4. Then we know that the term 4n squared will be cancelled off. And now we're left with 4n minus 3. And therefore, a minus b is greater than or equals to square root of 4n minus 3. Because in this case, a is greater than b. Once we successfully solve this problem, we may find that it wasn't as difficult as initially seemed. However, it's important to put in the necessary effort, keep trying, and sometimes rely on a bit of luck in order to identify the most suitable approach. So please remain patient in your efforts. If we're lucky enough, we may be able to solve the problem more quickly. As we continue to practice and refine our skill, our intuition will improve and will become better equipped to tackle similar challenge in the future. So this is the method that I use to solve this question. If you have an alternative method or any questions, please feel free to share them in the comment. That's all for today's lesson. I'll see you again next time. Bye bye.